Hey everyone, welcome back. So today we're going to be solving Leetcode 1011, capacity to ship packages within D days. The solution to this problem is very intuitive and very interesting. Yeah, so let's begin. The problem statement is that you have a conveyor belt that has to ship packages from one ship to another ship. Okay, and then you're given the weight of each package in terms of an array, where weight is the array, and then you have each element represents the weight of the ith package. Okay, and another constraint that is given to you is that you have to ship it to another ship within 5 days. Within 5 days, not equal to 5 days, not greater than 5 days, within 5 days. Okay. Each day we load the ship with the packages on the conveyor belt. We may not load more weight than the maximum weight capacity of the ship. Okay, that's another point. You have a capacity of the ship. You don't know that yet. That is what you have to figure out. But you cannot load more than that capacity. If you have defined a capacity, you have to load it lesser than or equal to that capacity. Okay. Now, another very important point is that each day we load the ship with packages on the conveyor belt in the order given by the weights. By this, what it means is that, let's say the weight that you have is 1, 2, 3. Whenever you're loading it, you have to load it as 1, 2, 3. You cannot load it as 3 to 1 or 1, 3, 2. You have to load it as 1, 2, 3. Okay. This order has to be maintained. Okay. That is a very important point. And that is also mentioned over here. If you see, this cargo must be shipped in the given order. So you using a ship of capacity 40 and splitting the packages into two parts, 2, 3, 4, 5, and 1, 6, 7, 8, 9, and 10 is not allowed. Meaning, I cannot ship 2, 3, 4, 5, 1 at like one day, and then I cannot ship 1, 6, 7. I have to ship it in order. Okay, so this is another constraint. So basically our point is to find the weight capacity of the ship that will result in all packages of the conveyor belt being shipped in days, within whatever days that is mentioned. Okay, now yeah, we have to find the least capacity, meaning that minimum weight. If you're not given this point, this particular word, then it doesn't mean anything, right? It's not even a medium level problem, it's an easy level problem, because you can return any weight. You can return the weight equal to the length of the weight array. It doesn't matter, but the thing is we have to return the least weight. Okay, this is where the problem gets interesting. Okay, now okay, and also we have to discuss the constraints, right? Yeah. So the constraint that is given to us is that the days and the weight length, that is, the weight is the array and days is the number of it is a single int variable. It can range from 1 to 10 power 5, 5 into 10 power 4. Okay, 5 into 10 power 4. Now, ideally, it's given as 5 into 10 power 4. So if I get a approach of n square, that would be around 10 power 9, right? 10 power 8 and close to 10 power 9. 10 power 9. Now I know that if the n square is giving me 10 power 9, which means that ideally I cannot use n square because it would give you a TLE. That is known. So we need to find an approach better than that, which better and optimized than that. Okay, and that is exactly what we're gonna do. Okay, let's begin. Now, let me take this example, a smaller example. Let me consider 322414. 3, 2, 2, 4, 1, 1 and 4, and your days is 3. Perfect. Days is 3. Perfect. Now, we'll have to find the maximum weight. First, let's look at it visually. Let's see what we can figure out. Then let's go into the approach. Okay. Visually, what we can see is that number of days is mentioned 3, and I have to ship all these packages. Okay. So let's say that the weight per day that I'm taking is 3. I'm taking, let's say the weight that I'm considering per day is 3. Okay. So what am I going to do? The indexing, let me mark the indexing as well. Perfect. Okay. I've taken 3. Okay. Now, if I consider 3, okay, let me go through the array now. I can ship this package one day, correct. Now the weight is 3. So for the first day, it's done. I cannot ship. Let me consider days. Okay. Initially it is 3 because 3 on the first day I'm shipping 3 packages. Then I'm coming to the package 2. Now I've already reached the limit, which is 3. So the first day is over. I cannot ship anything more in when the weight is more than 3. Okay. Now let me take 2. Yes, I can ship 2 because it is less than the weight. Now how much weight is remaining that I can ship? 1. Right. Now I'll go here. 2 is greater than 1, so I cannot ship that. So I would need another day. Now I'm going to 2. Again, 2 I can ship. Okay. Now I'm going to 4. Now the sum is 6, which is greater than 3. Now I can't ship that, so I would need another day. 4. Can I ship 4? No, I cannot ship 4. So what can I do? Can I break 4 into 1 and 3? I can ship 1 in day 4 and then 3 in day 5. Okay. Now I'll go here. Yes, I can ship 1. I have remaining 2. Now I'll go here. Can I ship 4? No, sorry, not 4. The sum of these two is 5. Can I ship 5? No, I can't. So I would need another day. Can I ship 4 now? No, I can't. I have to break it. So I have to ship 1 at day 7 and 3 at day 8. So now this is giving me a result of 8. And what is the days that I need to ship it in? 3. So of course we cannot use this. What can be another weight? Can I consider, let's say, let me consider 6. 6. Okay. Now, can I ship 3? Yes, you can. Can I ship 2? Yes, you can. Weight is 5. So these two, I can ship it on day 1. I cannot ship this because it becomes 7. So I have to go to another day. Can I ship 2? Yes, you can. Can I ship 4? Yes, you can. Can I ship, now the sum has become 6. Can I ship 1? No, you can't because the sum becomes 7 and the weight you consider is 6. The days becomes 2. Can I ship 1? Yes, you can. Can I ship 4? Yes, you can. Because it becomes 5, you can ship it. Now this becomes 3. Now when the weight is 6, I can ship all of them in 3 days. Right? Makes sense. I can ship all of them in 3 days. So 6 can be my answer, cannot be my answer. I don't know that. Maybe or may not be. Okay. Now let's consider some element less than that. Okay. So if you have weight 6, if I consider 7 also, it's possible. Right. Makes sense. But let me consider weight less than that. Let me consider 5. Weight as 5. Okay. Let me mark this. Okay. Now weight is 5. Can I ship 3 and 2? Let me erase this. Okay. Now, can I ship 3 and 2 days? Can I ship 3 and 2? Yes, you can. Okay. Can I ship anything more than 5? No, you can't. So day becomes 1. So this 2 becomes my combination. Can I ship 2? Yes, you can. Can I ship 4? No, you can't because it becomes 6. So you'll have to wait for another day. You'll have to ship 2 and then wait for another day. Can I ship 4? Yes, you can. Can I ship 1? Yes, you can. But I can't ship this because it becomes 9. You have to wait for another day. Day becomes 3. Can I ship 4? Yes, you can. You come out. So you ship this on the 4th day. Okay. So if you see, the number of days that's taking you is 4, whereas the required number of days is 3. So you can't with 5. So the minimum value, if you can't with 5, you cannot with 4 also, 3 also, 2 also, 1 also, right? Now, can I say that now my minimum value is 6? Okay. So 6 is the weight that it takes for me to ship all the packages within 3 days, and that is the minimum value, because any value lesser than that, it's going to take more days. Okay, so 6 is my answer, right? And the answer we have here is also 6. Okay, so if you look at it visually, this is the approach we would follow, right? And this is the approach that we are going to use when we are going to come up with our optimized approach. Okay, now let's forget all that for a second. Let's just think about the approach that we would think of in a brute force way. Okay, day is 3. Okay, now in brute force, what can I say? See, I can consider 3 first, and then can I say that I can consider 3 and then I can keep checking through the array. Oh, sorry. And then I can keep checking through the array. Oh, keep checking through the rest of the array. Now I found out that it is greater at a point where I reach the days is greater than 3, I reset. What I do is I go to 2, meaning I combine these two and then check for the I combine these two. Okay, now after combining these two, I run from here to here. I check again. 5 is 5 possible. Okay, I take 5 as the weight, and then from here I combine the sum. Okay, and then I keep checking. If it's greater than 5, then I'm going to reset it, and then I'm going to reset it, and then I'm going to increment the number of days. Okay, now when this happens, what I do is I break. When the days is number of days exceeds the days provided, I'm going to break. Then again I'm going to come to 2, I'm going to do the same thing. Okay, this is our brute force way, right? Ideally this is what we would think of. Okay, but is this the right approach? It's not. Why would you do that? You're just iterating through the array again and again. Okay, now we have to find the optimized approach. Okay, this approach would ideally, I believe it would give you a complexity of n square. Worst case would give you n square, best case would be lesser, but the worst case would be n square, and we will receive it yearly because the constraints provided to us is 10 power 4, 5 into 10 power 4, which would give us 10 power 9 when we do n square. Okay, now we have to find the optimized approach, right? Let's think in a way of optimization. Okay, see, the first thing that I told you, whenever I considered a particular weight, and then I checked if it's possible, that is exactly the approach that we're going to be using. We're going to consider a weight, and then we're going to check if that weight, in that weight, if it's possible or not. If it's possible, we're going to hold that weight and check for some other weight. Okay, that is the approach we're going to do. But instead of iterating, but if you think about it, would we iterate through the entire weight range? Weight range can be anything, we will come to that, but let's say that we have a range from 1 to n. Okay, to find the minimum value, do we really have to iterate through the entire range? No, right? It's not required, right? Because once you find a value, you literally know if the value towards the left or value towards the right, if it's possible or not. Just like I told you, when I found out 6 was a weight, I know for a fact whatever is greater than 6 is going to be is not going to be the minimum value, right? So I don't even have to calculate this part. Okay, but I can calculate the left part. 6 may be our minimum weight, may not be a minimum weight. Okay, but for sure I'm not going to find a value greater than 6. Okay, now 5. Whenever I found out for 5, if I found out that it is possible, for 5, if I found out that it's, in this case it's not, but let's say if I found out that it's possible, then I'll update my minimum weight to 5. Now I'll know for a fact there's no weight towards the right which is possible. I have to go towards the left. But in this case, I have found out that I found out that 5 is not possible. So now I know for a fact towards the left of 5 also it's not possible for us to get the minimum value. Because of 5 itself is not possible, we're not going to get 4, 3, 2, 1. We're not going to get it, right? But let the range be anything, we'll come to the range. But if the given range of weight is 1 to n, okay, in that case, if I found out 5 is not possible, then anything less than 5 is also not possible, right? Makes sense. So now I can eliminate either the left or the right. Okay, now And then if I'm moving towards the left, which means that I'm moving towards the minimum value, I'm going to override the current value, and then I'm going to keep moving towards the left. Okay, that is the idea. Okay, now let's look into what range can we go through. Okay, what range can we go through? Let me erase these. Okay, now see, when I went through the problem, when I took the weight as when I assumed the weight to be 3, okay, and when we iterated through the entire array, when we came to 4, okay, I had to split 4 into 1 and 3, because if the weight itself is 3, how can I carry 4? It doesn't make sense, right? So I have to split it. I just split it into 1 and 3. Okay. Now tell me something. Is this actually feasible? Why would you waste 2 days on the same package? Not required, right? You don't have to. You don't have to. You can just consider that weight, right? By that, what I mean is, why not we consider the minimum weight that is required? Let's forget about the days for now. Don't even think about the days. Let's just look at the weights part. Let's just form a range so that we can use that to get the answer. Okay. Now let's just look into the weights part. Now, can I say that in a given array, I can consider the weight, the minimum weight that I need is the maximum value of the array? Can I say that? Think about this statement. Can I say that the minimum weight that is required to ship all the packages within D days is the maximum weight of the element? If I have 3, I have to split 4 into 3 and 1. If I have 2 as a weight, I have to split 4 into 2 and 2. Whereas if I have 4, which means that any package which is equal to or less than 4 will fit into it within 1 day. I don't have to waste more than 1 or 2 days for that. Right. So now I can say that the minimum value that is required is the maximum of the array. Can I say this? Yes, I can. Now, what will be our maximum value? What is the maximum value that it can go up to? Okay. Now, if you see over here, see the question that, let me show you the question again. The question clearly says that you have to return the least weight capacity for being shipped within D days. Within D days, meaning you have to ship it equal to or less than D days. Not necessarily 3 days. It can be 1 day also. It can be 2 days also. It can be 3 days also. But it cannot be greater than 3 days. That is what the question is asking us. So can I say that the maximum value that I can have for a weight is the sum of the array? I can say that, right? Now the sum of the array is 4, 8, 12, 13, 16. Sum is 16. Okay, this is the array sum. Okay, now if I have weight as a 16, okay, how would it look like? I will ship the first package. Okay, now I have 13 weights left. I ship 2, I have 11 weights left. Ship 2, I have 9 weights left. Ship 4, I have 5 weights left. Ship 1, I still have 4 weights left. Ship 4, I have 0 weights left. So can I say that with the sum as 16, I can ship all packages within a day or equal to a day or equal to a day Can I say this? I can, right? The question is asking us to return the weight within the days provided. Okay, so if my max weight is 16, yes, of course I can ship all the packages within 1 day. That is completely okay, and I can ship the entire thing, which would be nothing but the weight of the which would be nothing but the sum of the array. Okay, now max value, I can say that sum of array. Right, makes sense. Okay, if it's sum of the array, I can ship the entire thing within one tick, which is still valid. Okay. Now we have found our min value, our max value. Now, can I say that if I found my min and max value, I can find the least value using binary search? Think about it. This is where it gets interesting. Right? I just told you before this that if a given range is there, I literally don't have to iterate through the entire range to find the minimum value. It's not required. I can eliminate either of the halves based on the answer that I get. Right. So if I get any element as the least element, for now, I'm going to take it. I'm going to iterate towards the left. If I get any element which is not possible, then which means that I'm going to move towards the right. I'll come to that, but this is the idea. Now, whenever I found a value, I can move either towards the left or right. Okay. Also, I have a search space. Does this all qualify for the binary search algorithm? Of course it does, right? See, what do you need for binary search? It's very simple. Binary search, all you need is a search space. Now we have a search space where the minimum value is given, maximum value is given, and we have to search in between that value. What is the second condition for binary search? Let me write it down. Binary search. The first condition is range. The first condition is range. The second condition is range is nothing but the search space. What is the second condition? Second condition is the capability to either to move to either halves, either the first half or the second half. Right. I mean, that is why it gives you the time complexity of log n, because you're breaking one half and then you're considering the other half, and in that half you're breaking it again, considering one half, and you're doing the same until the breaking condition is met. Right. Makes sense. So the second thing that I need is validity to break and consider either of the halves. Can I say this? Yes, I can. Right. So these two are the major conditions that I need for binary search. Okay. A third thing would be a breaking case, and breaking case is it would be nothing but until low is less than or equal to high, and this would be almost same every time. Right. Now I have a search condition, I have a search space, and I also have a validation which would either take me to the left half or the right half, always. Right. Now can I apply binary search on this, wherein what I'm doing is I would consider a mid element. Okay, I would consider a mid element. Just a second. I consider a mid element. Okay, this is my mid element, and I'll have two conditions over here: to move towards the right or towards the left. Okay, so here, when will I be moving towards the left? We already discussed this. When will I be moving towards the left? When I found a value which can be shipped within d days. Right. For example, in that iteration that we went through, when it was 3222414, 3222414. Okay, when we went through this and I assumed the weight to be 6, okay, we got the value as true, as in by true I mean it can be shipped within 3 days. Right. When I found out that, what did I do? I immediately moved towards the left, because I know for a fact it's not going to be present, the minimum value is not going to be present on the right. The same thing. Okay, for minimum value, I'm going to say if the function, this would be a separate function wherein we are checking if it's possible to do it in n number of days with the given weight. If the function is returning me true, okay, now I know for a fact I can move towards the left. Move left. By moving left, what does it mean? Right equals to move towards left. Sorry, towards left. Right equals to mid minus 1. Make sense? Okay. Now, what would be my condition where I have to move to my left? Now, let's say that instead of 6, let's assume that I didn't find out 6 first. I gave it as 5. Now, for the same thing, I assumed it to be 5, the weight. Now, with 5, what was it? It was 3, 2 on day 1, and then 2, and then 4, 1, and then 4. So this was 1, 2, 3, 4. It took 4 days. Okay. Now I found out that, hey, it's not possible to do within 3 days, right? Because the days that is given in the problem to us for this one is 3. Now when I found out that, can I say that anything towards the left of that is also not possible? If 5 itself is not possible, can I do it with 4? Of course not. Can I do it with 3? No. 2? No. 1? No. I cannot do it. So is there any point for me to search it on the left side? Is there any point for me to search it on the left side? No. There's no point for me to search it on the left side, right? So then I can move towards my right. So what I'm going to do, if it returns false, I know for a fact on the left side it's not possible. Then I'm going to move towards right. So here it's going to be left equals to mid plus 1. Okay. And when is this going to go till? Till breaking condition would be low is less than or equal to high. If this condition breaks, then in that case our binary search would break and it would return us the final answer. Okay. There's one more point I forgot. If it's true, I told you, right, we're going to hold the value. So whenever I find a value, it may or may not be the minimum value, right? It may or may not be the minimum value. Okay, so I need to hold that value. So what I'm going to do is I'm going to hold the value in answer. I'm going to update the answer to minimum of answer and mid. Math on minimum of answer and mid. And then I'm going to keep moving. So this is the approach that we are going to follow. I hope you understood. Let me code it. You'll get a better idea. But this is ideally how binary search would be applied. Okay, that's very interesting and very intuitive. Let's code the solution. Okay, so let me let me write the function which checks if it's possible or not. So I'm going to call it public. This is going to return boolean if possible, and then I'm going to have int arr, int weight, and then int days. So I'm going to have int sum equals to 0 initially and int count will be 1 initially, right? It makes sense, right? Because you would return at least 1. Why would your count be 0? You would return at least 1 because it would take at least 1 day, right? Now int I equals to 0. Okay, while I is less than array dot length. I'm going to iterate. I'm going to check if sum plus array of I. Okay, sum plus array of I, if it is greater than weight, then what do I have to do? I have to reset and increase the days. I have to reset sum to 0 and then I have to increment the count by 1, right? Okay, let me show this. Okay, count by 1. Now Else what would be a condition? Else, which means that it's not greater, so I can keep incrementing my sum. Plus equals to 1, sorry, plus equals to array of I and I plus plus. Okay, now can I add another condition? We don't have to unnecessarily go through the while loop entire time. Can I add another condition where if count is greater than days, then I'm going to return false? Valid, right? Now here I'm going to return true, right? Perfect. So we are done with our checking if it's possible function. Now we're going to check, now we're going to apply binary search. So I'm writing it in a way so that you can understand, but we don't need so many variables with what I'm going to write. I'm going to consider int max equals to integer dot minimum value. Okay, int sum equals to 0. So for int I in weights, what am I going to do? I'm going to go through the weights, right? Yeah, weights max equals to math dot max of max comma I can say that, and sum plus equals to I can see this. Now what I'm going to do is int low equals to max, int high equals to my sum. I can see this, right? So that's the reason I said you don't need to have so many variables. You could shorten it, of course, but I've written it so that it's easily understandable. Okay, now we would apply our binary search while low is less than or equal to high. Okay, my int mid would be low plus high by 2. Okay, ideally the best practice would be to write it as low plus high minus low by 2, but it's okay because the constraints are less, and this is just to handle overfill condition, so it's okay, right? So what I'm going to do is I'm going to hold the result in a boolean type, and I'm going to call if possible function with the array and what the weight and the days. Okay, weight would nothing but mid, right? And then I have days over here. Good. Now if here is where our condition is. If result is true, again you don't have to write it like this, you can just give if result, but I'm just writing is true. Okay, I need another variable int ans equals to 0. Okay, what I'm going to do is answer equals to math dot min of answer comma mid. Okay, what am I going to do? I found that out. Now if my answer is true, what am I doing? I'm moving my right pointer to mid minus 1. Okay, and that's what we're going to be doing. Right equals to mid minus 1. Okay, if it's not true, else it'll be false. Else I can just say left equals to minus 1. Done. Okay, now finally what will I do? I'll just say return. Right, looks good. Let's just check once again. Minimum value, sum is 0, 1 weights, I am going to okay I, and then low equals to max. Okay, high equals to sum, answer 0, low is less than or equal to high, to volume minus 1, left middle plus 1, doing that. And then here what I'm doing is sum is 0, count is 1, I is 0, I is less than, count is greater than equal, returning false. Okay, sum is greater than weight. I'm making sum as 0 and count as I'm creating the count, and then sum plus equals to area of I, and then I'm doing I plus plus. Okay, sum plus equals to area of I plus plus. Okay, it looks good. Let's try to run it. Okay, I still got an error. Sorry, this is supposed to be weights. Oh, once again. What is it? Cannot find simple weights. Sorry, now it should work. I'm sorry. It should be high equals to mid minus 1 and low equals to mid plus 1. Okay, we got a wrong answer. Not sure. Output is 0. Okay, output is 0. Return to. Okay. Let's try to debug it. If that is true, answer is return answer is 0. Lowest max highest sum plus I. Okay, answer is 0. Lowest is less than equal to high. Mid is low plus high by 2. High plus low by 2. If result is a positive, weight mid and taste. Okay, it's correct only. Result equals to 2. And answer is math.min of answer and mid. High equals to mid minus 1, low equals to mid plus 1. Just false, which means I'm not false. I'm going to increment the answer plus 1. Okay. And back here, boolean it's returning I is less than array dot length. Count is greater than this. Okay. Okay. Low is less than equal to high. Okay. Why is it returning 0? Okay, I think I know why, because answer is given as okay. Yeah, makes sense. Okay, so the reason it's returning 0 is because it's considering the minimum value between answer and mid, and any value that is present would be greater than that, so it doesn't make sense. So I should not do that. I should hold it in a different I should hold it as a, if I'm gonna get if we're going to get a minimum value, then I need to hold it as a maximum value. Max value. Okay, now it makes sense. So answer is max value, so it's going to get the minimum value, comparing it with the mid. Okay, let's try to run it now. Perfect, looks good. Let me submit it. Perfect. Now the last thing, what is the time complexity of this approach? This is taking us the complexity of n, this thing. Okay, what would be the complexity of this? What is our low? What is our high? Okay, we'll be going from low to high, right? Yeah, we'll be going from low to high, right? Now this would take us a time complexity of O of n, and this would take us a time complexity of log of sum minus max, because our low is nothing but our max and high is nothing but our sum. So it would be log of sum minus max. So our complete complexity would be time complexity of O of n log of sum minus max. This would be our time complexity, right? Perfect. And our space complexity would be O of n, because we're using constant space. It's just variables that we are assigning the values to, so that should be good. Okay, yeah. This is the optimized approach for this problem. I hope you understood this. This approach is very intuitive, and it's very interesting. Okay, it's not easy to come up with, but it's very interesting. Yeah, I would suggest solve problems similar to this, so that you get a better understanding. Okay, thank you so much for watching.